What is chemical potential? Explain with examples. Have you ever wondered how substances interact and change in energy? Understanding chemical potential can help us answer that question. Chemical potential is a key idea in thermodynamics that describes how energy is shared within a system. It tells us how much energy is associated with 1 mole of a substance in a specific environment. To put it simply, when you add a small amount of a substance to a system, the chemical potential indicates the change in energy that happens. Think of it like this. If you were to add 1 mole of sugar to a cup of tea, the chemical potential would representing the energy change that occurs from that addition. Just like how electricity flows from high to low potential, particles move from areas of high chemical potential to low chemical potential. In thermodynamics, chemical potential plays a role in the fundamental equations that describe how energy changes in a system. These equations include factors like temperature, entropy, pressure, and volume. By understanding these relationships, we can see how energy is distributed and how systems reach a state of balance, known as equilibrium. Now, let's look at some examples. In chemical reactions, the chemical potential of the reactants and products helps determine if a reaction will happen spontaneously. If the products have a lower chemical potential than the reactants, the reaction can occur naturally, releasing energy in the process. Another example is phase transitions, like when ice melts into water. At the melting point, the chemical potential of the ice and water is equal. This balance is what allows the transition to happen smoothly. Osmosis is another interesting case. Here, water moves from an area of lower chemical potential, where there is a higher concentration of water, to an area of higher chemical potential, where there is a lower concentration of water. This movement continues until equilibrium is reached. In electrochemistry, chemical potential is also essential. In batteries, ions move based on their electrochemical potential, which combines both chemical potential and electrical potential. This movement is what powers our devices. Chemical potential is closely tied to entropy and spontaneity. A spontaneous process is one that increases entropy or decreases energy. By comparing the chemical potentials before and after a process, we can determine if it will happen naturally. If the chemical potential of the products is lower than that of the reactants, the reaction is spontaneous, indicating energy is released. In essence, chemical potential is a fundamental concept that helps us understand how substances behave and interact based on their energy states. It is vital for grasping various natural and industrial processes, from simple reactions to complex biological systems.